Hello guys, I hope you're doing well. So here we have a 4-bit multiplier and divider circuit. Okay, so what the circuit basically does, it takes two inputs, input B and input A, and it computes the product of A and B as well as the quotient of A and B based on the mode selected. Okay, so mode 0 means division and mode 1 means multiplication. So actually right now we are in mode 1 because in the mode select pin is actually equal to 1 right now. And if you look here, we have the multiplication output as well as the division output. So at the multiplication output, we simply have product of A and B. And now at the division output, we actually have the integer part, which is here, the integer of A and B, as well as the modulus part, the modulus of A and B, which is also known as the remainder. Okay, so let me just show you guys with a few examples. So here I have 0, 1, 0, 0, which is 4, and here I have 0, 0, 1, 0, which is 2. So 4 times 2 should give me 8, right? So let's run it. As you can see, I have 8. Let me try to change it up. Let's try maybe another example. Um, so here, this is, wait, no, it's gonna overflow. Okay, so here I have 1, and here I have 6. So 6 times 1 should give me 6, right? As you can see, I have 6. So another thing to take note here is this is a 4-bit multiplier, right? So that means if you try to multiply numbers that are going to give you a result larger than 4 bits, you're going to have an overflow error. Okay, so that's something to keep in mind. So that means essentially my range is limited to 0 to 15 in this case. So let me try maybe another example. Let's try uh, let's try 4 times 3. Okay, 4 times 3. So 4 times 3 should give me 12, right? So also another thing to note here, these displays, they show me, hexadecimal numbers. So for example, let me just run it. If you look at our output, right, it's written C. This is C hex, C hexadecimal, which is actually equivalent to 12 decimal. Okay, so that's another thing to note. So all of these displays that I'm using, they show numbers in hexadecimal format. So let me try another example. For example, let's try something like 3 times 3. So 3 times 3 is 9. Let me try maybe something else. Let's try 2 times 3, 6. Let's try 5 times 2. 5 times 2 should give me 10. As you can see, A is basically A hexadecimal, which is equivalent to 10 decimal. Okay, let me try maybe one more example, and then I will, let's try maybe 2 times 2. 2 times 2 is boring now. Let's try, okay, 2 times 2. 2 times 2 is fine. So as you can see, I have 4. Okay, one last example maybe. Uh, maybe, okay, I don't know. Um, okay, 5 times 3. 5 times 3 should give me, this is fx, which is 15. Okay, so now let's move on to division. So for me to do that, I need to switch the mode to 0. Okay, so now we are in division mode. And also I need to switch off the switches for multiplication, like this. And I need to turn on the switches for division, like this. Okay. Okay. So right now already we have 5, right? 5 divided by 3. So what is 5 divided by 3? Is simply what? 1 remainder 2, right? So let's run it. As you can see, I have 1, the integer part remainder 2. Let's try another example. Let's just say, okay, 6 divided by 3. Again, 6 divided by 3, we know that is what? 2 remainder what? 0. Let's try 6 divided by 2. It's going to be 3 remainder 0. Let me try, let's try something else that is a little bit more fun. Okay, this is going to be 15. 15 is also known as fx. I'll just say 15 divided by 5, which is going to be 3 remainder 0. Let's try another example. Okay, let me first stop it. So here I have 1101, which is basically 13, right? Which is 13. So 13 is essentially going to be, I think it has to be d. So 13 is essentially dx, if I'm not mistaken. What is 13? Yeah, I think it has to be dx, yeah. So 13 divided by 0101, I'm gonna get something like, so 13 divided by 5, we know the answer, 2 remainder 3, right? And as you can see, we have 2 remainder 3 here. What else can I try? What else can I try? Let's try 13 divided by 7. Okay, 13 divided by 7. We know that's going to give us 1 remainder 6, right? Let's run it. And as you can see, 1 remainder 6 here. Let me try something else. And also, like I said, this is d. This is d hex, which is 13. So, always put, take that into account. Let me try maybe another example that is a little bit interesting. 9 divided by 3. We know that's going to give a 3 remainder 0. And let's try 9 divided by 2. It's going to give us 4 remainder 1. 8 divided by 2, 4 remainder 0. What else? Yeah, so essentially, I think you guys, you get the idea. So it works perfectly. So yeah, you know, that's the multiplier and divider circuit. So now let me just explain a few things and as to how it works. So I've already uploaded my videos on the multiplier circuit as well as the divider circuit, right? So essentially what I simply did here was I combined them together. I combined the multiplier circuit with the divider circuit because I realized the components are the same for both circuits. The only difference was, the comparator stopping condition. So the comparator in this case basically is like the decision maker, right? So once I realized that, I was like, okay, yeah, I think I can just add, multiplexers. So as you can see here, I have max 1, which is the first multiplexer. This is the 2-to-1 multiplexer, and then I also have a second one here. So what these multiplexers simply do, they select the appropriate inputs for the comparator. So essentially, you know, that's how I'm able to switch between the multiplier circuit and the divider circuit. So like that's the whole idea here. So everything else is the same. You see full adder, memory, comparator, counter, everything else is the same. But the only difference is these extra maxes here. So yeah, that's the whole idea, guys. And thank you, for tuning in. So if you want to, learn more about digital electronics, you know, be sure to leave a like or even comment if you want to. So yeah, that's it, guys, and see you in the next one.